Hey everyone, how goes it? Welcome back to Computer Science 145. I'm Dr. JJ Shepard, and today we're going to discuss basic computation. So as we are developing programs, we're first going to discuss procedural programming. As we know, a computer consists of two major components, hardware and software. In hardware, we understand that the CPU runs a program's statements one at a time. This starts from the entry point and reads it left to right, top to bottom. We also understand another piece of hardware is called the memory, and this stores the information that can be accessed and modified by the CPU. Going into more detail, we are developing Java programs. These are organized first by projects, then by classes, and then by methods. We're going to be using some terminology a lot, but whenever we refer to the body of something, it is whatever is in between the curly braces. So for example, this is the class, and this would be the body of the class, everything in between those curly braces. Methods in Java need to be written inside of classes, and the body of the method is in between these curly braces. Now, more specifically, the main method is Java's entry point. This is where the CPU knows to start reading the information. So a lot of our code is going to be written inside the main method at first. Now, in order for us to do basic computation, we need to be able to store information. One way that we could do this is by utilizing variables. Variables store data such as a number or a character, and you can consider it as basically being a container or a box. Storing information is implemented by using memory. The value is the name that we called the stored data, and values are stored in a memory location. If we remember, every memory location is denoted by an address which holds the value or the information. For variables, values can be changed. Now, in order for us to use variables, we must declare them. This can be as though you're speaking to the computer and saying, I need a container of this size called this name. Declaring a variable requires the variable's type followed by an identifier, as we can see right here. Also, for argument's sake, anytime you see these open and closed double angle brackets, that just simply means put something there. So as we can see in this example, we have this type called int and this identifier called number of cats. Now looking into this further, let's discuss what are types. Now types correspond to the type of data and the number of bytes that are in memory. Programming languages may either be strongly or loosely typed. Java is considered a strongly typed language because we have specific kinds of types for different kinds of data. We only use the type when declaring a variable and nowhere else. Now, there are two major types. One's called a class or an object type, and the other is called the primitive types. Primitive types are used for simple values such as numbers or single characters. Class types are used for a class of objects and combine together both data and methods, which is functionality. One thing to keep in mind about class types is they're separated by a reference that refers to its contents. And we discuss this a lot more later. Looking more specifically at these primitive types, we have a couple of different classifications. One of them is called an integer, and you can consider these as whole numbers. Some of the types for integers can be used as byte, short, int, and long. For this class, int is the most common whole number type. Floating point or decimal types can either be float or double, and in this class, double is going to be the most common one. Character type only has one type called char, and there's only one Boolean type called Boolean. Now, as we can see over here, these are examples of different values that can be of these types. Whenever we refer to an integer type, it has to be a whole number. Integers just cannot become decimal values. They will always be integers. Decimal values always should include the decimal. This is a very good idea to avoid logic errors because if it's a whole number, the compiler may only consider it to be an integer. But if it always has a decimal, then it knows that it is a floating point number. Characters are denoted by single quotes. Strings are denoted by double quotes. So a single character requires single quotes. And the Boolean type only has two values, true and false. As mentioned before, types correspond to the amount of memory that is required to store that information. And as we can see right here, these are the different data types with their corresponding size. So for instance, an integer is 4 bytes in memory. If we remember, there are 8 bits in a byte. 8 times 4 is 32, and 2 to the power of 32 gives us all possible numbers that an integer could store, which range from this to this. Now similarly, a double is actually short for double precision floating point number. It means it doubles the size of what is a regular float. We can see a float is 4 bytes in memory, so a double is 2 times that, 8 bytes. Now again, there's 8 bits in a byte. 8 times 8 is 64, so you have 2 to the power of 64 possible numbers that could be stored inside of a double, and this is sufficient for storing 15 decimal digits. A Boolean is only 1 bit, 0, 1, true or false. And a character, for the most part, is only 2 bytes. But do keep in mind, characters are just numbers as well that we represent lexically. Now that we've explored types, let's talk about identifiers because they have special rules. An identifier is a name, such as the name of a variable. And identifiers should be meaningful. The identifier should tell you what that is being used for. Now, identifiers may contain only letters, digits, the underscore, and the $sign, which does have a special meaning. But for argument's sake, stick with letters, digits, and the underscore. Identifiers cannot have any kind of space. Also, identifiers cannot start with a digit. Identifiers should not contain dots, asterisks, or other types of special characters. Also, when we're using identifiers, we must understand that they are case sensitive. So if I were to declare 4 different variables, stuff, 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 and stuff, they would all be considered different identifiers. Now furthermore, identifiers cannot be a reserved word. These are words that have special meaning inside the programming language. Now, identifiers do have some naming conventions that we generally stick with. For instance, class types always start with an uppercase character, for example, a string. Primitive types start with lowercase characters like int, double, boolean, char. Now, variable identifiers of both start with a lowercase character. Multi-word identifiers are punctuated using uppercase characters. We do this so that these values can be more easily read. Now over here we have some good examples. As you can see, this starts with a lowercase character, and it does not start with a digit. We just put those at the end there, so test 1. This double has 2 different words, large and values. Notice that we uppercase the V, and this makes it a little more readable for us. Same thing for Boolean, in, and class. We lowercase the first character, but then uppercase every word after that. Now down here are some bad examples. This variable started with a digit. We can't do that. That's a syntax error. This variable has a space in between it, and we cannot use spaces. But we still want it to be readable, so this is why we uppercase every other word after it. And this one, Boolean class. We know that class is a reserved word in Java, so this would be an error as well. Looking at this in more detail, in order to use a variable, we have to declare it. We have to tell the CPU to say, hey, we need this much space to store this type of information. If we look at this example to the side here, if we start, we are going to declare an integer I. And over here are some byte addresses that's just been arbitrarily picked. So what we do is we declare this integer I. So what it effectively does is it puts this identifier in memory, and then our contents are here. Java is a programming language that assumes default values, and you can assume that the default value is going to be 0. Now, if we're going to declare another type of variable, j, then what we do is the same thing. The identifier is stored here, its contents are set to 0, and also notice we did include the decimal point here, and now its byte address is at 32. Now the reason why we're pointing this out is if we start at this byte address 28, we know that integers are 4 bytes in memory. So going from 28 up until 32, this is the contents of the integer value. We also know that doubles take up 8 bytes in memory. So once we get to character O and we declare that, we add 8 plus 32, which now this character starts at byte address 40. Its identifier is over here, and this is the default value for characters. We don't usually use this, but it's just good to know that this is the default value of a character. Now we're not sure what could be declared next, but we know that the next available byte address is 42. The reason why? Characters are 2 bytes in memory. 40 to 42 is the character that we store here. So now we know how to declare variables. That way we can store information inside of them, but how do we add values to them? We use the equal symbol, and that's considered the assignment operator. Now the assignment operator is different from the mathematical symbol equals, because in math, when you do equals, you're saying that the left-hand side is equal to the right-hand side. 2 plus 2 is equal to 4. In programming, the assignment operator stores whatever is on the right-hand side into this identifier here. We can assign values as long as they're valid, so this means if the type matches or they're at least compatible. For primitive types, you can store inside of other primitive types as long as the type's byte amount is less than or equal to the value that is being stored. So in other words, you can store an integer, which is only 4 bytes, inside of a double that's 8 bytes. But if we were trying to do it backwards, store a double that's 8 bytes into an integer that's only 4, then we have to do something called typecasting. Now keep in mind, typecasting does not round. It simply cuts off everything past that decimal point. We can see here that this is an example of typecasting, where simply enough, we take this identifier, and then in front of it, inside a parenthesis, we put the type that we are casting it to. So, if you ever needed to convert a double into an integer, this is how you would do it. Now you could declare and then assign values in multiple statements. Or you could do it all as one, but keep in mind, this is a shorthand. It's always good programming practice to assign initial values, and we could simply shorten this into one statement. Now keep in mind, types are still not used after their declaration. If we look at this example down here, there's actually 2 statements per each line. First thing right here, this part is the declaration. This is what we saw before. This basically creates this identifier at this byte address and go ahead and assigns it to the default value 0. Now this part is the assignment. We assign I to the value of 0, which isn't that exciting because it's already 0. Moving down to the next statement, the first thing is we declare this variable j. So this reserves 8 bytes in memory and then assigns the value j is equal to 22.3. We move down again. We declare this character O and then assign it to the value the character h. Now we reach right here. Notice this. We don't use the type for I. We don't say int I because I has already been declared. If we were to do that, we would get a syntax error because we cannot have multiple identifiers that are the same. So, we're going to convert the value that's stored inside of j and store that into I. But as we know, doubles contain 8 bytes in memory, integers only contain 4. In order to make this possible, we typecast it, which is why we have this int inside a parenthesis here, which converts this value into an integer. But notice, what this does, it doesn't round, it just cuts off everything past that decimal point and stores it right there. Now, similar to variables, we can also store data in what's called constants. These establish values that cannot change, and we must assign the value initially. Using constants is a great programming practice because we can then avoid certain things like magic numbers. Now, a magic number is just a number that appears inside a code for no rhyme or reason. It appears as though it's just magical. Whenever we define constants, we give context to these values. In this way, we can make more readable programs. Now, to use a constant, it's really good to make its scope public and also to make it static. We'll discuss what both of those mean in a future lecture. Also, it's really good programming practice to capitalize all the characters in a constant's identifier. As we can see here, this is how we can create pi and also maybe another thing called board size. Notice that all of these are uppercased, and we separate each one of the words using an underscore. So now we know how to create the containers and store information. Let's do something interesting with it. Let's start applying math to these values. Now, whenever we're talking about math operators, keep in mind that what happens is this part right here is evaluated first and then stored inside this identifier. Inside of computing, we still adhere to the order of operations. Keep in mind, this can create a lot of different logic errors if we're not careful. Our basic math operations are simply addition, subtraction, multiplication, which is an asterisk, and also division. We also use this very special kind of operator called the mod. This returns the remainder after division. So as an example, we can see 15 mod 2 is 1. That's simply because 2 goes into 15 7 times with a remainder of 1. Now, as programmers, we are not lazy, we're efficient. As we've seen before, sometimes we create shorthands to make our life so much easier. The one that we saw before is how we can both declare and assign values. In addition to this, there's also these things called compute and assign operators. So basically, they're just a shorthand for applying some sort of operator to a value of a variable. So some of the most common ones are like plus equals. This adds the value and then assigns it. Minus equals, times equals, divide equals, and even mod equals. As we can see over here, if the value of I was assigned to 32, when we do plus equals 128, it becomes the value of 160, because it adds the value of 128 to 32 and then stores it back into I. Now just like here, if j was assigned to the value of 28 and we do mod equals 2, it's now assigned the value of 0 because there is no remainder after division of 2. There's also two very special versions, plus plus and minus minus. Basically, these are shorthands for plus equals 1 and minus equals 1. So as you can see up here, this example where I is assigned to I plus 1, or I plus equals 1, or I plus plus are all the same statements. And you should pick whichever version that you like best. In this way, you can start finding your programmer voice as you're communicating with the machines. Going further than that, there's also e-notation, which allows numbers to be written in scientific notation, as we can see there. Couple other notes to keep in mind. Whenever we're talking about floating point numbers, like a double, they are approximations as they are finite. The thing is, our memory only has a limited amount of space. So if we were to do 1.0 divided by 3.0, So as we know, 1/3 is 0.3 repeating, and that 0.3 repeats until infinity, but we don't have an infinite amount of memory. So if we were to do this calculation, it's slightly less than the actual value of 1/3, as it's just an approximation. This also means if we were to add 1/3 plus 1/3 plus 1/3, it may be less than 1. These type of round-off errors can cause severe logic problems in software, so do keep this in mind that floating point numbers are not perfect. Also, integers are always integers. Anything past the decimal point is always going to be cut off. You can also consider this as it will always round down, or it takes the floor. So for example, if we were to do 1 divided by 3, this is equal to 0. There is no decimal point in integers, they are always whole numbers. This absolutely can cause logic errors if we are not careful. Now that we know how to do this basic computation, let's talk about how we can input and output. Now for right now, when we're talking about input and output, let's just consider it to be done inside the console. And this is the command line interface that we're interfacing with. The console outputs or writes left to right, up to down. Console inputs or reads information left to right, up to down. Now whenever we need to output information, we can use the command system.out println, and inside the argument, we can say what to output to the console. Now the system.out println prints out whatever the argument is and then adds a new line after it. It skips down the next line. A variation of this is called system.out_print. Now this time, the argument is printed out, but it does not jump to the next line. The way you can always think about this is these methods, print and print line, print to the standard system output, in other words, the console. We see the example right here where we declare this integer I, assign it to the value of 22, and then we call this print line, which will print the value 22 to our console. Basic input can be achieved by using the scanner. Before we can use the scanner, we must include java util.scanner at the beginning of our file. This allows us to create an instance of this type scanner that scans the standard system input. So as you can see right there, this is declaring a new instance of this type scanner that we call keyboard. And then we construct it, tying it together to the standard system input, in other words, what's read in from the console. Most of our discussion has revolved around primitive types, but the scanner is a class type, which means that it has methods or functionality that's very useful. For instance, some of the most useful ones are .next, .nextLine, .nextInt, and .nextDouble. In addition, the scanner can also be used to read strings, files, network traffic, basically anything that can be streamed. And we'll talk about that a little later on. Now in this example, we create this new instance keyboard and tie it together to our standard system input. Then what we do is call string name and assign this to keyboard.nextLine. So if I were to enter JJ and press enter, the name that's assigned here is JJ. After that, we declare this int I and then assign it to keyboard.nextInt. So then if I were to enter 64 and press enter, the value 64 is stored inside of I. You'll notice here that we have this comment that says this is a useful fix-up. Whenever you use the commands like nextInt or nextDouble, it's usually a good idea to include this. That way we don't accidentally have an error that we'll talk about later. Now just like right here, we now declare this variable j and we assign it to nextDouble, so if I were to enter 3.14, press enter, the value 3.14 is stored here. We then use our fix-up after the nextDouble, and then we just print out the name plus a space, plus the value of I, plus a space, and plus the value of j, which this is what's outputted here. We inputted the values JJ64 and 3.14 and outputted those values formatted just like this. Now that we've seen all this, let's see a program. So we're going to develop a program to solve this problem. We need to be able to convert inches to feet. Now once again, we understand that Java programs are organized inside of projects, followed by classes, then followed by methods. The first thing that we're going to do in our IDE is create File, New, Java Project. I'll call it CSCE145 inches to feet. We're not going to create a module. Now that we've created this project, we need to create the class. I'm going to right-click our source folder, src, and add a new class. I'm just going to call this inches to feet, and also include my main method, the entry point of the program. I'm going to go ahead and get rid of this comment, and the first thing I'm going to do is write my name. Written by JJ Shepard, inside a comment. Make sure to always do this. It's very important, and points may be deducted if you forget your name in your projects. Now, we know we're going to be getting some kind of user input. So before we write anything else, we need to include the scanner. So import java.util.scanner. That way we can use that type scanner. Now, as we remember, the curly braces indicate the body of something. This open curly brace and this closing one indicates the body of the class. Methods in Java need to be organized inside of classes. So this open curly brace and this closed one is the body of the main method. Now, if we remember, the main method is the entry point. So the CPU starts running the commands starting from inside of here, one at a time. The first thing that we do, after we have imported Java util scanner, what we need to do is set up an instance of that scanner, and we call it scanner keyboard equals new scanner system.in. This way, we create this new instance of this type scanner, call it keyboard, and tie it together with our system.in. That way we can read from the console. Now we need to prompt the user. In order to prompt the user, we need to utilize the standard output by using system.out. And let's just say we're going to print line. So we just print out greetings, give a height in feet, and I will give the number of inches and feet plus inches. Now we need to get that input from the user. We need to figure out what the type is. Would it make sense to use a whole number in this case? Well, maybe not so much. I feel that this could have a decimal value. And any time that we know that we may need a decimal value, we first need to declare a type double, followed by the identifier, which we're just going to call feet. So this creates the variable, the container, that we refer to as feet. And now we can store that information inside of it. What I'm going to do is then use feet. Now notice, we don't use the type again. We only use double when we declare the variable. Now what we're going to do is assign that using the equal symbol, and we're going to capture this information from the console. So then we call keyboard.nextDouble. Whenever the user enters a double value, it's then stored inside of this variable. Now, whenever we use nextDouble or nextInt, it's usually a good idea to also include keyboard.nextLine. Now that we have the information, we have to be able to convert the feet into inches. And as we know, there are 12 inches in 1 foot. Now, the value of 12 needs to be used, but here's the thing. That value is never modified. That is a constant value. It's good programming practice to create a constant value instead of just using the value 12, because that could just be a magic number. Now I'm going to define this constant outside of the main method. So I'm going to create a public static final. Now what's the type of this constant? Now the type I'm going to use is type double, as we were using double before. So now we got to create the identifier, and the general rule of thumb is if it's a constant, we need to uppercase all the characters. I'm going to call this inches to feet and define it as 12.0. Now what we can do is calculate the number of inches given this feet amount. We need to store this in a different container. So once again, we declare double, and this time we're going to call it inches. And we're going to then assign this to the feet value that we have stored right here, multiplied by the constant inches to feet. Now this solves the first part because given a height in feet, we have the number of inches. But then we also want to separate this out into the number of feet and also the number of inches inside of here. This requires a couple of more variables in order to do this. To make this interesting, we're going to declare the variable int I feet, so the whole number value of feet. And this is simply equal to inches divided by the inches to feet. But there's a problem here. Both of these values are type double, which means this is 8 bytes in memory. An integer is only 4 bytes in memory. In order to convert a double to an integer, we need to typecast everything. I'm going to go ahead and put this inside a parenthesis. That way it calculates this value first, and then we typecast it to an integer. Now once we've got the whole number value of feet, we need to get the remaining inches. So we got to create a container, and I'll call it int rm inches. And then we're going to assign this to, well, how do we determine how many inches are left over? What is the remainder? Whenever we need to get the remainder, we need to utilize the mod operator. To do this, we're going to take inches, and we're going to mod it by inches to feet. But once again, this is type double. We need to store this in an integer. To do this, I'm going to go ahead and once again put it in parentheses so this happens first. And then after that happens, we typecast it as an int. Now that we have all of that, let's output this to the user. We're once again going to use the standard system output and print to a new line in concatenated with the value of feet, concatenated with the value of inches, concatenated with the whole number value of feet, and the remaining whole number value of inches. Let's see if this runs correctly. So running this, we first prompt the user. And let's say we're going to enter the value 5.5. And as you can see right here, in 5.5 feet, there are exactly 66 inches, or 5 feet, 6 inches. The key ideas from this lecture was understanding how we can store information in memory and how we could do basic computation on those stored values. We utilize things like variables and constants in order to do these calculations. With all that being said, I'll see you next time.